a video of motion in a plane. First, let's deal with vectors. The x-axis is indicated by an I cap, a y-axis is a j cap, and a z-axis is a k cap. The I, j's and k's represents the directions of the x, y and z axis. It only represents the direction, it has no magnitude, or in other words, the magnitude of an I cap is 1 and magnitude of a j cap is 1 and magnitude of a k cap is 1. Okay, so coming back to supposing you have a coordinate here which may be 1 comma 2 comma 3, a 1 from the x-axis, a 2 from the y-axis and a 3 from the z-axis. But in vector we don't say it as 1 comma 2 comma 3, we call it as 1i. The position vector p can be called as 1i plus 2j plus 3k, and so the origin is 0i plus 0j plus 0k, and this is called the point p is called the position vector. The position vector, okay, and this is called the line vector. You join OP vector is the line vector where it's x2 minus x1 into I. Supposing this is x1 y1 z1 and this is x2 y2 z2, it's x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. So it's 1i 1 minus 0 into I plus 2 minus 0 into j plus 3 minus 0 into k, which is turns out to be 1i plus 2j plus 3k. If they ask you what is the magnitude of this vector, its root of the component squares 1 square plus 2 square plus 3 square, which is 9 plus 1 10 10, so 10 plus 4 is 10 plus 4 is 13. 10 plus 4 is 14, I'm sorry. Okay, so then 9 plus 1, 10, 10 plus 4, 14, yeah. So this is the magnitude of this vector, of P vector. Okay, next is, so this is from the origin. Suppose it's two different position vectors such as 1, 2, 3 and this is 2, 5, 9. This is point A and this is B, and AB vector is x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k, which is 2 minus 1, 5 minus 2 is 3j, 9 minus 3 6k. So thus you get the line vector, and suppose they ask you the magnitude of this vector. It's root of the component squared, okay, which is root of 1 plus 9 plus 36, 36 plus 9 is 45, so root of 49, so it will be 7. No, 45 plus 1, okay, 45 plus 1 is 46, so it's root 46, whatever be the value, forget about the numerical part. Just understand the conceptuals. So this is what is a magnitude of an AB vector. Suppose they ask you for converting this vector into unit vector. The unit vector formula, okay, is the vector by its magnitude, AB vector by magnitude of AB, that's the formula. So 1i plus 3j plus 6k is the vector, and that divided by its magnitude is root of 1 square plus 3 square plus 6 square. I would have given a different examples here on the PDF, but it's the same thing that I am teaching. So in general, a vector, supposing AB vector is like AI plus BJ plus CK, in general you can say the magnitude of AB vector is root of A square plus B square plus C square. Supposing they ask you to convert this vector into a unit vector, it's AB vector by magnitude of AB vector. Okay, so AB vector is AI plus BJ plus CK by the magnitude is root of A square plus B square plus C square. That's how we can convert the vector into its unit vector. The thing that I have explained here is the unit vector is the one whose magnitude is unity. So look at this, I have found a unit vector from the PDF that I have written 1i plus 2j plus 3k by 14, root 14 is the unit vector, the vector by its magnitude. If you try to find the magnitude of this vector, it will be root of 1 by 14 plus 4 by 14 plus 9 by 14, which will be root 14 by 14, it's 1. The meaning of a unit vector is the magnitude of that vector will be unity. So that's what it means, unit vector. So next is two parallel vectors. Supposing you have, I will stick to the PDF example. You have 1i plus 2j plus 3k. To be a vector, you want to write a parallel vector, you can write lambda times 1i plus 2j plus 3k, where lambda is some constant, okay. So in theory, you can also say one vector is a1i plus b1j plus c1k and a2i plus b2j plus c2k. The condition for these two vectors to be parallel is a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda. So that's about it. Next is dot product. A dot product, the hidden factor is cos theta, so its magnitude of A into magnitude of B into cos theta is what is a dot product. The example is work done, which is force vector into displacement vector, is work, but this answer is a scalar. Okay, so supposing they are going to ask you to dot and 1I plus 2j plus 3k with 3I plus 7j plus 9k as quoted in my PDF. You know, you can only dot an I and a I, a j and a j and a k and a k, because I and if you're going to I and a j, it will be perpendicular, you know, x-axis and y-axis, 90 degree, and cos 90 itself is 0. Because a dot product has got to cos theta, you can only dot an I and I, a j and a j and k and k. So dotting means mere multiplication, 3 plus 7 2s are 14 plus 9 3s are 27, whatever be the answer for this, I've written it as 44, and you get a scalar. Can you see there's no I, j, k's anymore, because the I square when multiplied is 1, j square when multiplied is 1, so then it's just 44, and you get a scalar quantity. Thus work done is a scalar. When a dot product of two vectors will result in a scalar. Next is about a cross product. The cross product is about an A cross B, which is magnitude of A into magnitude of B into sine theta is the formula. And you have to include an n cap just to indicate that the result, that the answer that you get is in vectors. It may be an I cap or a j cap, some vector there, so n cap. So let's take an example. 1I plus 2j plus 3k is been crossed with a 3I plus 7j plus 9k here. You know, when crossing, you can only cross an I and a j, I and a k. You cannot cross an I and I, because angle between them is 0, because the cross product involves sine theta, sine 0 is 0, the entire answer will become 0. Therefore, you can only cross an I and a j, an I and a k, a j and an I, a j and a k, and a k and an I, and a k and a j. But for me to multiply, you know, I'm very bad with numbers, and I get really, I do make a lot of mistakes. So this is a shortcut that I can teach you to find the cross product. The cross product goes like this, it's I, j and k. Okay, 1, 2 and 3, 3, 7 and 9, write it as a determinants like this. You put I into minus j into plus k into, and you can doing I into, just ignore the row and column in which I is and do top to bottom minus bottom to top, which is 18 minus 21. I hope you understood. So it's 18 minus 21 here, and minus j into, ignore the column in which j is there, column and row, top to bottom is 9 minus 9, it turns out to be 0. So I'm sure you understood, it's 9 minus 9, and a plus k into, ignore the column in which k is there, 7 minus 6. So it's 7 minus 6 is 7 minus 6 is just 1. So thus you end up getting a this some random example that I have given, and you are doing a cross. Okay, well, I'm crossing, I have given a different example here. So you understood that it can be minus 3i plus 0j, minus 0j, it doesn't matter, plus or minus, so which means there's no j component at all, that's what it means, plus 1k. Of course, the example I've crossed some of the vectors 1, 2, 3 and 2, 4, 5 in the PDF that I've done it. I've done different numbers, and you end up getting a vector. That no wonder a cross product is a vector, and no wonder you put an n cap here to indicate the resultant is a vector. And the real life example of this is torque, which is force into displacement, but we write as r cross f, and you end up getting a vector. When you cross two vectors, you end up getting two vectors. So that's about it, and you learn the shortcut method of finding a cross product. Supposing they ask you angle between two vectors, the vector is 1i plus 2j plus 3k, another vector is 3i plus 5j plus 9k, and they want an angle between these two vectors. You know, in a dot product, A dot B is magnitude of A into magnitude of B into cos theta, right? Using this, you can write the formula for cos theta, which is A vector dot B vector by magnitude of A into magnitude of B. What is the dot product of these two vectors? You know, it's 3 i's and i's and j's and j's and k's and k's, so 3 plus 10 plus 18 by the magnitude of A. Let's consider one vector is A, another vector is B. The magnitude of A is 9 plus 25 plus 49. The magnitude of B is 1 plus 4 plus 9. Thus you get a cos theta. And so you want the angle, you can take the theta cos to the other side. Cos inverse of whatever is the answer that you get. Inverse. Cos theta when taken to the other side becomes cos inverse. Thus you can find the angle between the two vectors. Okay, next is I told you, as I told, okay, this is the condition for parallel vectors. What is the condition? A1 by A2 is equal to B1 by B2 is equal to C1 by C2, or that vector is lambda times another vector. Two ways in which you can say about parallel vectors. Now is perpendicular vectors. The condition for perpendicular vectors is A vector dot B vector is equal to 0, because cos theta will be cos 90, right? So that's the condition for perpendicular vectors. In other words, it's A1 A2 plus B1 B2 plus C1 C2 is equal to 0 is the condition for perpendicular vectors. Because I told you it's A1I plus B1J plus C1K is one vector, A2I plus B2J plus C2K is another vector from the PDF. You dot it, you get A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So these are the two ways in which you can express the condition for perpendicular vectors. Next is, in physics, whenever you have a vector like this, you can break it down. If it's force, you can break it down into F cos theta and an F sin theta, where theta will be the angle between the force and the horizontal component. Suppose you have velocity like this, you can break it down into V cos theta and a V sin theta, and the resultant, this will be theta. Okay, actually, yeah, so this is what it is. Okay, so coming back to triangle law of vectors. What is triangle law of vectors? A law of vectors. You can refer my PDF for the better handwriting. You have an A vector like this, you have a B vector like this, you have a C vector like this, all of them in the same direction, then A vector plus B vector plus C vector is equal to 0. Suppose you have an A vector like this and a B vector like this, and the C vector in the opposite direction, you can say C vector itself is A vector plus B vector. This is known as triangle law of vectors. Next is a parallelogram law of vectors. The parallelogram law of vectors is like this is A vector and this is B vector, and you want to find the resultant. Okay, to do the resultant, you know that this C vector, which is in the opposite direction, can be called as resultant. So then you have to construct a vector, B vector, parallel to the B vector. There's no lambda times, it's only parallel means you should have a lambda, but lambda happens to be 1 because opposite side of the parallelogram are equal magnitude. So if you want to do a resultant now, you can join this end and this end and you get the resultant R. The angle between the two vectors itself is theta. Then I'm going to construct this into a right triangle, extend this and extend this. Can you see a B which is on slanting, which can be broken into two component, which is a B cos theta component and a B sin theta, which will be here, which is also parallel to the purple vertical line. So we can write this as B sin theta, a B cos theta and a B sin theta. And therefore now you have a full right triangle here, from which you can write what is Pythagoras theorem, hypotenuse square. Hypotenuse, which is R, is equal to root of base square plus height square, which is A plus B cos theta the whole square plus B sin theta the whole square. So R itself is root of A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. B square cos square theta plus B square sin square theta, when added, just becomes B square. So A square plus B square plus 2AB cos theta. In a parallelogram law, you get it with a plus. Just remember this, the resultant of a parallelogram. An additional point that I would like to say is, supposing the resultant is making an angle phi. Okay, we can also write tan phi to be B sin theta, which is opposite, by adjacent, which is A plus B cos theta. A plus B cos theta. I'm sure you understood this. Okay, that's another thing that I told you. Okay, next is that's a tan phi that I've written there in the corner. I've just narrated that. Now let's go to triangle law. That's next is law of sine. Law of sine. Very, very important, law of sine. What is law of sine? It's A by sine A is equal to B by sine B is equal to C by sine C is what is law of sine, and how to derive it. Let's draw a triangle. Mark this as A, this is B and this is C. And there's angle B here and opposite it is small b. Angle C is here, opposite is small c. Angle A is here, opposite is small a. Now, can you see you have a sine B here? So let's start with that. Let's start with a sine B. And a sine B is opposite by hypotenuse, and therefore I need to construct a right triangle to find sine B, and the right triangle I have to construct AN, wherein I can write sine B to be opposite by C, because hypotenuse we have C. So therefore the opposite side itself is C sine B. Now therefore write this as C sine B. Now using this triangle you wrote this. Now take this triangle. And can you see that you want to find what is sine C, because you need a sine C from the derivation. So sine C is equal to opposite, which is C sine B, by hypotenuse, which is B. Juggle it around, you get a C by sine C is equal to B by sine B. That is only partially I have derived. I have not addressed the side angle A, right? So now I have to address the angle A, wherein I am going to do the triangle once again. You have an A, B, C, and you not write sine A. You need a sine A, which means you need to construct an altitude wherein the altitude is for which contains sine A is this Bn. And I can do the opposite of angle A is small a, opposite of angle B is small b, opposite of angle C is small c. Now we are going to do sine A, which is opposite, which is Bn, by the hypotenuse, which is C. Therefore Bn itself is C sine A. Just fill it in, C sine A. We took this triangle, we did this. Now take this triangle. Now write what is sine C. Sine C is opposite, which is C sine A, by hypotenuse, which is A. So therefore you get a C by sine C is equal to A by sine A, if you reciprocal and all that. Can I see this equation, first equation, second equation? Both of them are C by sine C. Therefore A by sine A is equal to B by sine B is equal to C by sine C, and this concludes law of sines, law of sine. Okay. Next is law of cosine. What is law of cosine? First, what is the law? And if you know two sides A and B, you can find the third side C, provided you know the angle between A and B. And the formula will be C is equal to root of A square plus B square minus 2AB cos theta. Unlike a parallelogram law where it was with a plus, the same kind of formula but with a plus, here it is minus 2AB cos theta. So then this is the proof I want to find, and let's take the same triangle again, an ABC, and you want okay, so we want to prove either C is equal to root of something like this. You can even find A is equal to root of B square plus C square minus 2BC cos theta, or you can find where theta is the angle between B and C. You can even find B, which will be root of A square plus C square minus 2AC cos theta. Whatever you want you can find with this. Okay. So if you know two sides and the angle enclosing the two sides, then you can find the opposite side. That's what it means. That's the law of cosine. And to find that, okay, which means I should, if this is A, angle A, this is angle B, so small b, angle C, so small c. And the whole purpose is to find, if I know two sides, like this side is A and this side is C, I can find B. Therefore the objective is find B, which has to be root of A square plus C square minus 2AC cos, the angle between A and C is B here, cos B. So this is the formula that I need to find, and to find that I need a cos B. So therefore construct an altitude AN and write what is cos B is adjacent BN by hypotenuse, which is C. Therefore BN itself is C cos B. Fill it in here. We got the BN, which is this adjacent side, which is C cos B. You know, this whole length is A. So therefore this half is A minus C cos B. Now you can find what is, take this triangle and use, you want to find B, that's the whole objective. So find B. The right triangle, B is equal to root of base square plus height square. You don't know what is height. Height is AN, which you already know from the previous thing, that is C sin B. From the, here you know C sin B from the first proof that we did, you know. See here we found it to be C sin B. So then therefore you have a C sin B. In this triangle you have opposite and adjacent, C sin B the whole square plus A minus C cos B the whole square. When you whole square and expand, you will get what you want. You will end up getting, this is a C square sin square B plus A square plus C square cos square B minus 2AC cos B. You know, C square sin square B plus C square cos square B is just C square. So A square plus C square minus 2AC cos B. We found one proof. We don't have to keep finding everything. You can put similarly and write A is equal to root of B square plus C square minus 2BC cos A. And C is equal to root of A square plus B square minus 2AB cos C. So this is the law of cosine. You can also square both sides and find the angles. Say take this A proof and square both sides. A square is equal to B square plus C square minus 2BC cos A. And so juggle the cos A to the other side. 2BC cos A is equal to B square plus C square minus A square, and the 2BC can come down. Thus you get a new formula for cos A. Similarly cos B will be um, what is other than b? A square plus c square minus b square by 2ac. Same pattern. Cos c will be, other than c you have an a square plus b square minus c square by 2ab. Like that you can arrive at all the cos formulas, or you can find the unknown side using the two known sides and angle contained in them. So you should know both ways of answering. Let's come to projectile. Projectile is like, if I am going to throw a ball like this, it is going to eventually fall down because of the gravity, but it's taking a trajectory which is parabolic. Yeah, and so imagine this to be a horizontal velocity u. That's the velocity with which I am pushing the ball, throwing the ball. It is travelled through a displacement of h or height h, and it's covered a range, horizontal distance r. And if you're going to use the s is equal to ut plus half at square formula here, instead of s you're going to write h, which means you're dealing with a vertical component, and you don't have a vertical component of initial velocity, you're only giving a horizontal component there, but you have a gravity which is down half gt square. Therefore, t square is equal to 2h by g, t is equal to root of 2h by g is the formula for time of full flight for this. And supposing they ask you the range, which is the horizontal distance here, again you use the formula s is equal to ut plus half h square, but instead of s you write r. It's a horizontal component we are resolving. You have an initial velocity u, you have a time, but there is no gravity in the horizontal component, so this becomes 0. And time for the full flight itself is root of 2h by g, therefore range is equal to u into root of 2h by g. You need to memorize both these formulas and also learn this derivation. To show that this is parabolic in nature, this is like a parabola. To show that it's parabolic in nature, consider at any instant of time t, the ball is here, which is at a distance of x from here and a y from here, obviously x from like this and y from here. Yeah. And any equation will be like y is equal to x square plus 2x plus 3, it should start with a y. So y is the vertical distance, which is vertical distance is y. And you're going to do s is equal to ut plus half at square, where I'm going to write s as y. It's vertical, u is 0, and there is no initial velocity. I have a half g a t square, this is what I have. So then that, okay, now we need to find what is t. Okay, now take the horizontal component. Instead of s is equal to ut, in the s is equal to ut plus half at square formula, right, this is x, the distance x, which is the horizontal distance here, yeah. X is equal to, which is the horizontal component. There is only horizontal component of velocity is just ut, but there is no gravity in horizontal component. This becomes 0. Therefore, t is equal to x by u. On substituting here, it's y is equal to half into g into x square by x by u, right? X square by u square. So you can group it as g by 2 u square, because all of these are constants. It's varying with x square, and y is equal to x square itself indicates as a parabola. So this two derivations is to prove that it's parabolic in nature. So that completes it. So next is what did I teach is like if I'm going to throw a ball like this. I'm going to impart a velocity which is like this, which is u. I'll have two components of u cos theta and u sin theta. There's both horizontal and vertical components there. This is the maximum height it can reach. Yeah, and this is the total range. So let's calculate the time of half flight here, t half. How to calculate? You have to use the formula. The clue is here. The velocity at the highermost point is 0. Therefore, I am going to use the formula v is equal to u plus at. When I write that and when I write velocity as 0, which means I am taking the vertical component. The vertical component of initial velocity is u sin theta. The gravity is minus g because the ball is thrown upward, gt. This is t is for half the journey because I have considered only this part of the journey where the velocity gets to 0. So t half itself is u sin theta by g. Therefore, t full, time of full flight, time of ascent is equal to time of descent, and so then 2u sin theta by g will be the formula for the time of full flight. Now, the second part is I am going to calculate this height h. So the velocity at that point is 0, so it's ideal to use v square minus u square is equal to 2as, where v itself is 0, u is, when I consider this, I am going to find the height, which means the vertical component, I am considering u as 0, the topmost velocity is 0. U should be u sin theta, which is u square sin square theta, which is the vertical component, minus 2g and h. So minus minus get cancelled, so h is equal to u square sin square theta by 2g. That is the h maximum height that the ball can go up to. Next is to find the range, which is this range, and you can use the formula S is equal to ut plus half at square, where S itself is a range, and range is the horizontal component, and u cos theta will be the horizontal component and time will be there, but gravity will not be there in the horizontal component, so you can leave it as 0. And this is for the time of full flight, because range covers the entire distance. So t is the time of full flight, which you already know. So substituting there time of full flight is 2u sin theta by g. You get r is equal to 2u square sin theta cos theta by g. And as I told you, the pure science students should know sin 2 theta is 2 sin theta cos theta. So 2 sin theta cos theta sin 2 theta, r is equal to u square sin 2 theta by g. So this is the formula of the full range, and we did numericals. We did some numericals with it, which I am sure you can understand. The question goes like this: a man stands on the cliff 490 meters above the ground, so which means, and he's going to he's going to throw a stone. Okay, if you don't know, you can always assume it as a ball if you don't understand my handwriting. Giving it a horizontal velocity of 15 meter per second, it's going to follow this trajectory. The time of the fall, time formula is root of 2h by g. The height itself is 490 meters. So quickly substitute that and find the answer for time of full flight. Okay, now next is find the velocity when it hits the ground. This is something I didn't include in the derivation. The time when it hits the ground, this is the velocity component, the direction of the velocity when it hits the ground, which can be broken down into components such as a vertical component, which is Vy, and a horizontal component, which is Vx. And if you construct this into a triangle, can you see that this is also Vy, and this is the resultant velocity V, the center, this is the resultant velocity V in which it's going to come. So V is equal to root of Vx square plus Vy square is what Pythagoras Theorem says. And let's find what is Vx. Use the formula u plus at. The x itself shows that horizontal. You have an initial velocity, but you don't have a gravity. So this itself is u square. Let's find what is Vy. Put u plus at again. In the vertical component, this has got no initial velocity, but it's got gt. So g square, t square. Substitute the respective g's and t's there. Time for the full flight you would have calculated, substitute, you get answer. So let's go to the next question. A bomb is dropped from an aeroplane when it is directly above the target. Okay, this is the aircraft. A bomb is getting dropped, but the aircraft keeps moving at a speed of, this is at a height of 1000 meters above the target, and it is moving horizontally with 500 kilometer per hour. You have to convert into meter per second, which is into 5 by 18. 500 into 5 by 18, which is 2500 by 18 meter per second is the velocity with which it's traveling. Now this is going to drop a bomb which will not have initial velocity 0, because it will have the same velocity as the moving aircraft. So initial velocity is the horizontal velocity 500 kilometer per hour, which is in this direction, is going to follow and go like this. It's going to definitely miss the target, and how distance is going to miss the target is nothing but the range. And r itself is u into root of 2h by g. Yeah, and you have u, h, g, g will be positive, no negatives here. You get the answer. So that's about it. This is all I took today. I hope you're all clear. Become thorough, write your own PDF, and we'll continue next class.